For this problem, we were wanting to find the equivalent impedances as seen through these two terminals. Okay, so the first thing that we want to do is to make sure that we have everything in terms of impedance. So for our 10 ohm resistor, it's just going to be 10 ohms. For our 30 ohm resistor, it's going to be 30 ohms. Now for our capacitors, we know that ZC equals 1 over J omega C. So it's 1 over J, 2 times 10 to the third, and C is 50, is 10 to the negative 6. So that comes out to negative J10. Remember that 1 over J is the same thing as negative J. Okay, so then our ZC for our other capacitor is going to be 1 over J omega times C, which is going to be negative J times 25. For our inductors, it's going to be J omega L, so J 2000 times 10 which is going to be J20. Now with my equivalent impedances, I can redraw my circuit. And replace the capacitors, resistors, and inductors with the equivalent impedance, which is in the frequency domain. So I'll just bring over the values from the last slide. Okay, so now I know that I have 30 in series with this and those combined are in parallel with J20. Okay, and so remember impedances in parallel add like resistances in parallel. So I'm going to add these and then take the inverse. So if I find a common denominator, J20, which is the same thing as 30 minus J5 over 600 J plus 500. Okay, remember that J squared equals negative 1. So when I multiply 25 times 20, but is multiplied times J squared. So that's why the negative 25J and 20J term ends up being positive. Okay, so I want to take the inverse of this. So I end up with 500 plus J 600 over 30 minus J5. And I have two options here. I can either find this in polar coordinates to do my division, or I can multiply times the complex conjugate, which is 30 plus J5. So we'll do the latter for that example. 30 plus J5, and I end up with 12,000 plus J over 925. And that ends up being 12.97 plus J, 22.162. Now remember, when you do complex conjugate here, you FOIL it. The outside-inside terms will cancel out, and so you're left with 900 plus that squared, which is 25. So that's where that term is coming from. Okay, so moving forward, now that I have this term in parallel, these terms here, now I need to add them in series with that 20 ohm resistor. So my 12.97 plus J, 22.162, is in series with my 20 ohm resistor. So now I have 32.97 plus J, 22.162. And this term is now in parallel with my J10 term. Okay, so again, I want to add in parallel. So 32.97 plus J, 22.162 is 1 over negative J10, and I would take the inverse of that. Okay, 32.97 is J, 22.162, negative J times 3 to 9.7 plus, 221.62. That equals 2.67 minus J, 10.98. And finally, this whole term is in series with that 10 ohm resistor. So I end up with 12.67 minus J, 10.98 ohms. It's my equivalent impedance.